my Visual Studio Code. I had it set up previously. It's called test.py. You can definitely do that. You can pretty much write anything here and save the file and run it and be able to see the output. And this is what we're going to do moving forward in these exercises, is to show you the top portion in code and also the terminal output, right? So let me just go through maybe a couple of examples here. Before we get into the while loop, let me maybe just illustrate what we talked about earlier regarding variables and the implementation and decrementation of a variable. Let's say n equals 5, right? This is one example that we had there. If you said n equals n minus 1, what happens? Well, this one variable n, starting with the value of 5, now it's going to be variable, it's going to be 4, right? So if we do print, you can pretty much see what's going on here, right? Line 2, print 5. Line 5 here, print 4, right? So if I save it and run it, you're going to see 5 and 4. Okay, so this is decrementing itself. Now, you can also, instead of writing this, I'm going to comment this out. You can say, and this is in your reading too, right? If you want to save some computers, naturally your human typing here, you can pretty much say something like this. So this is a shorthand for n equals n minus 1. In computer science, we use n minus equals 1, right? So if we were to print this out, you can see exactly the same. So n is 4. So this way of shorthand writing applies to multiple operations. So you can say n, this means, this is the same as saying n equals n times 1, okay? So you can also say this is n minus 2. This is the same as saying n equals n divided by 2, okay? And we can have n plus equals 1. So what does that mean? This means n equals n plus 1, okay? So you probably get it. I'm going to comment these out so we can continue evaluations. So that's what happens. So now you know that every single one of these, this is what we call, by the way, statement. Okay? Because you're stating, right? You're stating that n is equal to 5. This statement consists of declaration, declaring a variable, declaring an n, right? Declaring n on the screen, right? This sets up 4 bytes of memory space. But this is the first thing that happens. The second part is what we call assignment, okay? This assignment says, and now that we have a memory space, I'm sorry, let me just do something like this so you know n is 4 bytes of memory space set aside in memory. Assignment of n to value 5, right? So now you have 4 bytes of memory space in computer. You're assigning this value to that space. If you don't assign n equals 5, what happens? Well, n can be anything, okay? Well, the reason why n is 4 bytes is because by looking at what's on the right side, which is an integer, it implicitly tells your program to set aside 4 bytes of memory space, 4 bytes for integer, okay? So this statement, it's basically 2 operations at once, okay? So, a lot of times in other programming languages, you'll see something called initialization. So number 1 and 2 is what we call initialization. Why? Because you're initializing a variable, you're declaring a variable, you're creating a space for it. You're assigning values to it. You're essentially initializing this variable. You try to put an initial value to it, right? So you see initialization. Even though this statement is very simple, looking at it, it's actually a combination of 2 different things. So these are sort of terms that you'll see in various different sort of contexts. Okay. Anyway, that's what I wanted to talk about variables and its updates. Yeah, let's get to a while loop, right? So let's just get rid of this. And let's say if we have a while loop like this. Let's just examine what happens here. Okay. Now you have count. So this is very similar to n. You can use anything, right, for variable name. If you mouse over, you see count is an integer y, because this is 0 is an integer, right? If you do count equals flow, what happens? Count equals flow, right? If you do count, it's a string. This is a numeric string. What happens? If you mouse over, it says count string. So Python automatically implicitly converts the type of a variable and set aside that much memory in computer when you declare them in a standard, okay, like this. Anyway, let's go back to count equals 0. So as long as the count is less than 10, what happens? Then it says count, it just basically keeps counting, right? It says count plus 1. So this is the same as writing, we can pretty much write this, count plus equals 1, right? So count plus equals 1 gives you what? Gives you 1, right? So the very first iteration, count is going to be 1. But let me just undo it. So count is going to be 1, right? And it goes back to line 3 again. And count is going to be 2, goes back to line 3 again. Count is 4, 5, 6. So if you run the entire thing, you'll see that count eventually reaches 9, and 9 is fine. But once 9 is incremented to 10, count is less than 10 is not going to be true anymore, right? So the exit and print equals done. And notice the one tap rule, right? This is one tap rule. Same thing. So this illustrates what we have in the very beginning of this lecture using a while loop here. You can also excuse me, kind of turn this around and says count equals 10 as long as count is maybe count is 9, and this is as long as count is greater than or equal to 0, right? So this means, let me start with 10. And count is greater than or equal to 0, but in this case, you want to do a decrement. Then just keep doing it until count reaches 0. So this is going to give you pretty much 10 iterations. Why? Well, because you have, sorry, hold on, let me go back. Let me make sure I have the right indentations here. And there are no errors. Essentially, when you mouse over it, this is what happens when you cut and paste codes. That does not have the right indentations here. So this file is basically complaining. Let me cut and paste the actual code here. Excuse me. And run this. You can see that it starts with 0, and it goes down to 8, 7, 6, 5, 4, 3, 2, 1. Eventually reaches 0. 0 is still in there because it says count greater than 0 to 0, right? If you take 0 out of it, then it'll just be count 9 all the way to 9 to 1. That will give you 9 iterations. But if you include 0 in it and run it again, you'll see 10 of these. So now you have 10 of these. There's 10 because 0 is included, right?